Okay, so we're trying this again, seeing if we're actually videoing it. We are going to be talking about lesson 8-1, and in this lesson we're going to be talking about negative exponents and 0 as an exponent. Now we're going to start with 0 as an exponent because it's just the easiest thing to learn, and I know we've talked about this before, but I just want to make sure that we really make that point, that any number to the power of 0 equals 1. Okay, so any number to the power of 0 equals 1. Let's look at 2,897 to the power of 0, it equals 1. Okay, moving down, we have 48 to the power of 0. It also equals 1. And finally, let's look at a negative number, negative 82 to the power of 0. It also equals 1. So I think that clearly we've made the point that any number to the power of 0 is going to equal 1. So we're really not going to dwell on that anymore because I think that hopefully by this time that is a concept that you all clearly understand. Okay, so let's move on to our negative exponents. Now, with our negative exponents, what we're looking at here is, and let me move this up a little bit so that you can actually see it. We have 2 to the negative 3. Now, one of the things that I want us to remember is that every whole number can be put over the number 1, this being 2 divided by 1, or actually 2, but we're taking this 2 to the negative 3, and I'm showing you that any whole number can be over 1, and we look at it as a numerator. When we have a negative exponent, it's telling us, hey, I am not a numerator. I am actually a denominator. I belong down in the denominator. So you're in essence flipping this. You're bringing it down to the denominator. Once you do that, notice the negative sign is gone now from that exponent. You don't see that anymore. So you have the 1 over 2 cubed, which actually equals 1 over 8. Because we all remember that it's 2 times 2 times 2. This exponent is telling us how many times you are multiplying that number. Let's look at another one. We'll move this up again a little bit, and we'll see 4 to the negative 2. We've done the same thing here. We've brought it down to the denominator so that we have 1 over 4 squared, which is equal to 1/16. So basically the same thing is going to happen with all of these. Now, you might say, what happens if I have a negative in my denominator? Well, you know what, that can actually happen. So let's say we've got 1 over 3 to the negative 2. This is, once again, an indication that I am not sitting in the place where I need to be. I do not belong in the denominator. I'm not a fraction of a number. I'm actually a whole number. So this is actually going to equal 3 squared. Notice when it comes up into that numerator position, and of course, once again, we can put that over a denominator of 1. Once we bring it into that numerator position, we now have 3 squared. The negative sign is gone, okay, and 3 squared is equal to 9. Okay, so in both instances, that negative sign is telling us when we have a negative exponent, it is saying, I do not belong where I am. You need to change my location. I am not a numerator, I am a denominator, or if it shows up as it does here in the denominator, I am not a denominator, I am actually a numerator. So what we're going to do is we're going to move on and we're going to do some simplifying of exponential expressions. So first let's tear this apart. just so that we know exactly what we're doing. Simplifying, we're bringing something down to its simplest form. Exponential means that we are working with exponents and expressions. Expressions are mathematical phrases, just like in English class. They're mathematical phrases. They do not have the equal sign, so they are not equations. They are just part of an equation. Okay? Kind of like a phrase is a part of a sentence. Okay, so we started out with 11m to the negative 5. What I've done here is I've shown us that the 11 is our coefficient. The m to the negative 5, that is our variable with a negative exponent. And we look at these as two separate entities. Notice I have separated them here. This 11 is a whole number. So if we're going to look at it in terms of fraction, that 11 would be, of course, a numerator. Now, this m to the negative 5 is telling us I do not belong as a numerator the way that 11 does. I am a denominator. So I brought that m down into the denominator. Negative sign leaves, and we now have m to the power of 5. So this answer, when we simplify this, we bring it to 11 over m to the 5th power. Simplifying with our variables means that we are no longer going to have a negative exponent. So in simplifying process, we no longer have negative exponents. We only will use negative exponents when the instructions tell us to write something in negative exponential notation, okay, which means that we would not have this fraction bar. But let's continue with simplifying some more of these, getting rid of the negative exponent. And we have 7s to the negative 4 and t squared. Okay, so 7s to the negative 4 and t squared. Remember, each of these we look at separately. Okay? Now, our 7 is definitely where it belongs. It is a numerator. The s has a negative exponent, so that does not want to stay there. But our t squared definitely has a positive exponent, and it is saying I am in the right spot, so I want to stay. But now we're going to have to take that s, and we're going to have to bring it down to the numerator, get rid of the negative sign when we bring it down here, and we have s to the 4th. So in simplified form, this is 7t squared over s to the 4th. Okay, let's look at one that is starting in fraction form, and we have got 2 over a to the negative 3. Okay, so what is this telling us? Well, what it's saying is that the 2 is perfectly happy where it is. The 2 is in its proper location. So we're going to leave 2 up there, and then we're going to look at this a to the negative 3, and we're going to say, okay, it's in the denominator. It does not want to be in the denominator. It is saying, by virtue of this negative sign, this is not where I belong. I am a numerator. So what we're going to do is we're going to bring that up. We're going to bring that a up here, right next to that 2, that coefficient of 2, and get rid of the negative sign. And now our answer to this is 2a cubed. Okay, so we've brought that up. Once we brought that up to where it belongs, we no longer have the negative sign. And one more problem. Let's have n to the negative 5 over v squared. Okay, so we're going to look at each one of these individually. The n to the negative 5 definitely saying not a numerator. I am not a numerator. I am a denominator. I belong in the denominator. So we're going to bring that down. And we're going to say, okay, well, the n is coming down, n to the 5th, getting rid of that negative sign. And now let's look at the v. Well, the v is saying, I'm happy. I belong down here. This is a good place for me. So we're going to leave him down there. Now, this leaves us without a numerator, but we know that we always have a numerator of 1. So since we always have that numerator of 1, we can leave that up there, and this gives us 1 over n to the 5th v squared. Let's pause at that.